Hello and welcome to Lab 8 on weather maps. I've been thinking about this lab for the last 3 days straight and thinking about, well, if I really want them to know about weather maps, what's the most important stuff to do? How should we go about doing that? So here's what I've come up with. And I've tried to keep it relevant. I've tried to keep it modern. I've tried to keep it current. And I've tried to keep it in such a way that hopefully by the time the assignment's over, you can actually look at a weather map and have an idea what's going on the weather map. So let's take a look. Everything's on the web these days, so I thought let's try to make it as web-based as possible. This is the National Weather Service, is the Sacramento page. Our local forecast office is the Sacramento office. This is what the National Weather Service forecast looks like. They give you current conditions at a station, Sacramento Mather Airport. Current conditions 64 degrees. The dew point temperature is 57. The barometer is 30.09 inches of mercury, which is equal to 1018.96 millibars. Wind speed west-southwest at 12 miles per hour. Visibility is 10 miles. Relative humidity is 77%. So they give you the upcoming up through Thursday, the highs and the lows each day. They give you a text forecast. There's also links down here to the radar image or the satellite image. So the radar image right now, it's in the clear sky mode. So it's in the very, very, very sensitive mode. So they're picking up like dust and insects. But when it's raining, it's often really interesting to see the storms roll in, looking at the Doppler loop. There's also a link to satellite animation loop. So you can see what's going on today, watching the clouds disappear as it heats up in the Central Valley. Those are some great links, all kinds of different options. Did you want to see what air masses we're dealing with, clouds or nighttime microphysics, all kinds of good stuff. Anyway, there's the forecast. I wanted to comment on the forecast discussion. So right here, there's a link to the forecast discussion. Right here, there's a link to the forecast discussion. Surprised up here there isn't a link. But the forecast discussion is really interesting. It's where they talk about the forecast. And part of it is a synopsis or a summary of the forecast. And at this point in the class, at this point in your geographic education, you should be able to make sense of this. So high pressure builds over the area, which will lead to a warming and drying trend over the week. So at this point, you should read that and go, oh, right, yeah, high pressure means that air is sinking. As the air sinks, it heats up and dries out. So it totally makes sense that they would say that there's a warming and drying trend, and that the breezy north winds will lead to elevated fire weather concerns. So then they discuss the forecast, and it really is a discussion of the forecast. Sometimes they'll talk about how this forecast is similar to other forecasts. Like I've actually seen them say things like, last year we had that small storm that slid in and the models didn't catch it, so I've bumped up the probability of rain, the chances of rain in the forecast today. So they talk about like their feelings about the forecast. So the National Weather Service, their detailed forecasts, some good stuff. Also links to things like experimental smoke forecast if you wanted to see what's going on with air quality. It's crummy. All right, that's one forecast. This is the national forecast chart. And I will include a link to this. This is like a general forecast. You've got the blue is cold fronts, the red is warm fronts, the purple is occluded front. So here's a storm system with probably cold air down here, warm air in here, cold air up here. Everything should be rotating counterclockwise. Everything should be rotating counterclockwise. It's got severe thunderstorms, rain. There's another storm down here, the low pressure, occluded front, cold front, and a warm front. Everything rotating counterclockwise around that. And then it's also got tomorrow's forecast, and you'll see everything move to the east as the westerlies blow the storms along. So we've got a new cold front. There's our occluded front and our cold front and our warm front, and that's moved from North Dakota over to Michigan, or Wisconsin rather. And then on Tuesday, it's moved from Wisconsin all the way over Pennsylvania and Canada. So that's nice, a little simplified view of where it's supposed to be rainy or thunderstormy or snowy or whatever. This is the daily weather map. This is a more detailed view. We still have fronts. We've got an occluded front, a cold front, a warm front, but now they've got isobars, which is air pressure, and there's some very useful snapshots. Here's the pattern of air temperature, lowest to highest. Some of the questions I'll ask you, what are the temperatures in this state or this region, or where's the high temperature, where's the low temperature? I would start with this. For the assignments, I'll include a link to the daily weather map that shows you high and low, 500 millibar chart, 24-hour rainfall totals on this simplified map, and the next level of sophistication, more details, more information. No, not that. That's the old simple one. You can look at archives. That's why I've put that one there. So there we've got an archived shot. This is Saturday, September 12th. Here's the archive with, again, that storm, low pressure, occluded front, warm front, and now it's got it as a stationary front. I think that's interesting. Now we're getting even more sophisticated. We've got fronts, we've got isobars, we've got cold fronts, warm fronts, occluded in purple, stationary fronts with the alternating symbols on either side of the line. And now we actually have weather stations. And this is where it starts to get at least more interesting meteorologically. So we've got the air temperature, 52. We've got the dew point temperature, 51. We have the weather, the current weather symbol, those two magenta lines, and then wind and sky cover. So there's no wind. The sky cover looks like it's totally covered. This station down here, air temperature, 55. Dew point, 55. So the relative humidity, is 100%. Wind looks like it's 5 knots. That's the little 5 knot symbol. 5 knots coming out of the southwest. So this map I would look at and go, well, it's intermediate between this. This is an intermediate map. It's still simplified because there's only one. We've got temperature, dew point temperature, wind speed, wind direction, and sky cover. So we have 5 elements of information. There's only a little bit more information in the other weather symbol. And this is the weather symbol. So you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 different types of information. We're going to ignore most of it. We're going to ignore, half of it. We're going to ignore about half of it. But the great thing is about this, and I understand as a student, often it's overwhelming and anxiety producing. Like, I'm going to have to look at this. This makes no sense. That's just completely overwhelming. Showing me this, not helpful. I have no idea what the hell's going on there. So let's jump in to the... All right, Lab 8, weather maps. What are we going to do? The key learning concepts. Here is what you are supposed to know when you successfully finish the lab. You should be able to recognize the symbols used to depict weather conditions at stations on weather maps. You should be able to analyze a weather map and to describe current conditions at various locations. So pretty much all I'm expecting you to be able to do is, if I give you a weather map, and if I give you the guides to what the various weather symbols mean, you should be able to decode the weather map and tell me what's going on at different locations on the map. You should be able to decode the weather station symbols. There's keys for all of that. You should be able to find specific humidity and relative humidity. And since the station information gives us temperature and dew point temperature, if you know dew point, you know what the specific humidity is. If you know specific humidity and maximum specific humidity, you can calculate the relative humidity. Find high and low air pressure on the map. That'll be pretty easy. Find where it's raining. Again, pretty easy. So we're back to this bad boy, the weather station symbol, the station model, as the Weather Service calls it. You can see there's a ton of information. Not all of it is super important for us. If you're a weather forecaster, if you're a weather geek, you might be totally fascinated by the 3-hour pressure tendency or the visibility in miles. It's just not that important for us right now. So here again is the weather station model. Still not helping, but the information every single time, the same information is going to be in the same location. So for example, upper left-hand corner of the model, the number in the upper left-hand corner is the temperature in Fahrenheit, 34 Fahrenheit. Lower left-hand corner is the dew point temperature in Fahrenheit. The dew point temperature is 32 Fahrenheit. Okay, so far so good. We got temperature, we got dew point. We have sky cover, that's the dot. How covered up is it? That tells you how covered up the sky is. The more colored in it is, if it's all colored in, the sky is totally cloudy. If it's colored in halfway, then the sky is half colored with clouds. Wind direction, I'm going to want that within 45 degrees. So in this case, I would look at that and go, well, the wind's coming from 315 degrees and the wind speed is 20 knots. There's 2 full-length bars. Each one is 10 knots, so the wind speed's 20 knots. The air pressure is probably the part that's going to be the most confusing. Everything else, you just look at it and it is what it is. Like that star, that's a weather symbol. I'm guessing it's got something to do with snow. I'd have to look it up. You'll have to look it up. That's why we make these charts, page after page after page of this symbol means this. Those are some sort. Yeah. Oh man. All right, fine. I'll tell you what that thing is. One little spiky thing. Some sort of precip. Intermittent fall of snowflakes. So that fits with the 34 on the ground with a dew point of 32. It's very humid and cold. So we have intermittent snowflakes. That's good fun. And then these are high clouds and mid clouds. I'm not going to ask you for any of that. If we go to the page of high clouds, I'm thinking those are probably cirrus. Dense cirrus in patches or twisted sheaves, usually not increasing. Okay. And then this is a mid-level cloud. It is altocumulus of a chaotic sky, usually at different levels. Patches of dense cirrus, usually present also. Well, that's fun. But yeah, we're not going to deal with any of that. We're going to deal with air pressure. Here's the full thing again. We're not going to deal with all of it. We're going to just deal with the important parts. Those are the important parts. So we've got in the upper right current temperature. In the upper left is current temperature. Bottom left is dew point. The arrow is going to be wind direction and the feathers are wind speed. Upper right hand, those 3 digits are the air pressure at the surface. And there's a little handy dandy guide right here. I will go on and on and on in just a bit about how to decode it, but I would come back here. So they only give you the last 3 digits. So if it's reported as 989, the air pressure really is 998.9 millibars. So this 989, those last 3, 989, those last 3, 012 is really 1001.2 millibars. 012, the last 3 digits, 012. And like I said, I'll go over that. Sky cover, how colored in the dot is, tells you how covered up the sky is with clouds. Present weather symbol, it's a cool little symbol. There's a chart, you get to look stuff up. All right, wind direction. So I will give you this diagram. Wind direction, I want expressed as a number to the nearest 45 degrees. So for example, if it's like that, I'd say, well, that's closest to 315. It's closer to 315 than it is to 0 or 360 degrees. So I would say the wind is coming from 315 degrees. 315 degrees. Another example here. Well, I don't know. Is it east, southeast? Is it east? Well, it's closer to east than it is southeast, right? So I'd say that's east. I'd say the wind's coming out of 90 degrees. Boom, done. I mean, your options are 0, 45, 90, 135, 180, 225, 315, 360, or 0. Wind speed, again, it's a long feather is 10 knots. Short feather is 5 knots. If it's just one short feather in the middle of the shaft, the wind speed is 5 knots. If there's no wind arrow, then there's no wind. And usually they put a double line around the circle so that you're sure they haven't made a mistake and just left off the line. So in this case, the wind speed would be 15 knots, 1.5 feathers, 15 knots. Whew, air pressure. Okay, said this before. I'll say it again. This is the most challenging part of the entire assignment, is going back and forth between what the air pressure on the map says and what it really is. So back in the day, before computers, they had bandwidth problems, so they would only report the last 3 digits of air pressure on the map. Shown on the map are the last 3 digits. So if standard air pressure average at sea level is 1013.2 millibars, that would be reported as 132. So they move the decimal over 1 and then just take the last 3 digits. 132 is 1013.2 millibars. They only report the last 3 digits. For the map, to figure out what the actual air pressure is, you take the real air pressure, multiply it by 10, and report the last 3 digits. I think I said that backwards. So to go from the real air pressure to the map, they take the air pressure, multiply it by 10, and then just report the last 3 digits. So again, if it's 1013.2, multiply that by 10, 10132, take the last 3 digits, 132. So that's going from, if you know what the air pressure is, how to report it on the map. So most of the time, almost all the situations we'll be dealing with, air pressure is going to go from a low of 980 millibars to a high of 1050.9. Oddly specific, but you do you. So there's the range. What is that? 50, 70, so about 70 millibars. There's a range of 70 millibars. So the air pressure is going from 980 to 1050.9, and I'm just going to break that up into 980 to 999.9, and then from 1000 to 1050. And I've put the last 3 digits in blue, so that if the air pressure was, for example, 980.0 on the map, that would be written as 800. If it was 999.9, that would be written on the map as 999. If it was 1000.0, that would just be written on the map as 000. If it was 1050.9 on the map, that would be 509. So if you look at the leading numbers, right? Once you're down to the 3 digits, you're only going from 800 to 900, or the leading digit is from 0 to 5, which is going to make it pretty simple. In fact, there's 2 things that are going to make this really easy for you to actually calculate. Well, there's no calculation. You just add either a 9 to the front or a 10 to the front. So if the number on the map is between 800 and 999, then you know the air pressure is between 980 and 999. You're going to stick a 9 to the front. If on the map it's between 000 and 509, then you know you got to stick a 10 on the front end. So if it was 000, stick a 10 to the front, move the decimal place over, and you've got 1000.0 millibars. So going from the map to reality, you take the 3 digits, the last 3 digits are shown on the map. From the map, you're going to take the reading, the last 3 digits, you're going to add either a 9 or a 10 to the front, divide by 10, and report the last 3 digits. So here's the way that would work. For example, on the map, we have a reading of 041. 041 is between 000 and 509, so you're going to add a 10. So now we've got 10,041, 10,041. Divide that by 10, you get 1004.1. So 041 on the weather map is actually 1004.1 millibars. Again, the last 4 digits are shown, so that would be 041. There's your 041. Stick a 10 in front, divide by 10, you get 1004.1 millibars. Sky cover, it's just how clouded it is. Dew point temperature in Fahrenheit, it is what it is. Current temperature in Fahrenheit, it's just the current temperature. The weather symbol is actually going to be a little squiggly symbol. It's a glyph, and some of them look like the thunderstorm is one of my favorites. Yeah, that's going to be an easy way of evaluating that. Like, what's the weather going on at whatever location? Then you got to look at the glyph and say, oh, the whatever, that squiggly line indicates dust or frogs or whatever. Visibility in miles, I'm probably not going to ask you about that. It's interesting, but whatever. It's not as interesting as air pressure and humidity. 3-hour pressure tendency, probably not going to ask you about that. 6-hour rain precipitation, probably not going to ask you about that. Although it's interesting, expressed in hundredths of an inch. So what the hell? This is the way it's going to look on the map. So here we've got the 79, the 70, the +4, the weird check mark, the 8, the 76, and the other 8. Those are for this weather station. This check mark, the +1, the 82, that's for another weather station that we can't see the rest of. So let's go through and attempt to decode this. Yeah, I don't care about, that's from another weather station. I'm not going to ask you about that. So the temp should be easy. Dew point temperature should be easy. Air pressure a little tougher. Pressure tendency, sky cover, wind speed, wind direction. At this point, you should be able to answer all of these questions, at least if I gave you the appropriate materials to decode them. So the temperature, let's start there. 79 degrees, that's pretty easy. Dew point temperature, that's 76 Fahrenheit, that's also pretty easy. The air pressure, it shows up as 070. So I look at that and go, oh, just a couple slides ago, it said from 000 to 059, you add a 10. So air pressure, if it's written on the map between 800 and 999, you stick a 9 down the front. If it's between 0 and 509, you add a 10. The number that we have is 070, so we're going to stick a 10 to the front and then move the decimal place 1 to the left. So 070, stick a 10 on the front, move the decimal 1 to the left, and 10070 becomes 1007.0 millibars. So we know the air pressure, even though it says 070, that's really 1007.0 millibars. This is the daily weather map. And let me zoom out, reset that. Go to the very front. So it's the daily weather map. The National Weather Service publishes these weekly. They're now by PDF. You can download old ones. And let's just take a look at the confusion that's going on here. So I wanted to talk about this is the daily weather map. This is the weather map that you're going to get for your assignments. I'm just going to give you one of these and say, okay, here's the map. Take a look at this day. I would strongly recommend getting a good reference map handy. Break that out, because I'm going to ask you questions about specific states. And if you get the wrong state, you'll get the question wrong. Even if you decoded the weather station correctly, you could still get the question wrong because you didn't know that was whatever, Wisconsin and not Michigan, or Ohio instead of Indiana. So back to the weather map. We've got fronts, the little triangles. Now everything's black and white again. Little triangles are cold front. The little semicircles are warm front. That's an occluded front. There's an L for low pressure. The isobars are every 4 millibars. So that makes it really easy to count. 1028, 1032, 1036, 1040. And then there's little spot numbers like that 141. This 1007. There's another 1007, 1006. Those are the air pressure in millibar. 1014, 1013. They're just kind of scattered on the map as to be helpful. So we have isobars every 4 millibars. Oh, right. So 40, 36, 32, 28, 24, 20, 16, 12, 8, 4, 0, 996, 992, 998, 984. So the lowest air pressure on the map is 984 millibars on this map. That'd be a good question. What's the highest pressure that we can see? Well, there's 1040 there, 1016. So looking at the overall patterns, there's high pressure there, high pressure there, high pressure there, high pressure there, but that's the high pressure, 1040, low pressure, 984. There's some low pressure there, but it's not even below 1,000. So what I was going to say is you can also use the isobars to help you double check the air. You can use the isobars to help you double check that you've converted the pressures correctly from the weather station. So you'll notice that that's 1020, 1016. So they're every 4. If that's 1016, the next one should be 1012. And if we zoom into this weather station, you'll see exactly, hopefully, what I'm talking about. Right. So this line, I've lost my pointer. So this line right in here is the 1012 millibar line, and the air pressure as reported is 11.9. So if it's between 000 and 509, you stick a 10 in front, so that would be 1011.9 millibars. The temperature is 69, the dew point is 67, the skies are completely clear, the wind is out of the south at 10 knots, the visibility is 10 miles. And yeah, they seem to all have this. The air pressure went up 1 millibar in the last 3 hours. That's what the plus and minus, it's the pressure tendency in the last 3 hours. So down by 11, and then the check mark. So it went down, it was dropping, and then it's kind of steadied out. It dropped, and then it rose. Let's look at another one just for fun. Oh yeah, that one. That looks like a good one. So here, same deal. Oh, it's dry too. And I need to put this in writing for you. The higher the dew point temperature, the more humid it is. The higher the dew point temperature, the higher the specific humidity. The lower the dew point temperature, the drier and the lower the specific humidity is. In fact, the dew point temperature, it's just a proxy. It tells you what the temperature, what the specific humidity is. So the higher the dew point, the higher the specific humidity. The bigger the difference between them, the drier it is. So here we've got the air pressure. Let's start there. This is over here 1008. So this is probably 1012. This is probably 1016. And looking at the numbers, right? So if that's 1008, they should be around 8. 1007.2. Here we've got 1010. Here we've got 1011.4, 1011.6. Over here, this is the 1016 millibars. So we've got 1014.7, 1016.6, 1017.2, 1017.1, 1017.1, 1012.7. So back to this one though. The air pressure 1011.6, the temperature 64 degrees, the dew point temperature 29 degrees. I believe that's the visibility is obscured by smoke. The wind speed looks to be 15 knots coming out of the southwest. So that's how we would decode that station. So the whole point of this is pay attention to the isobars. Like if this is one, it's 097. If the numbers on the map are between 0 and 500, stick a 10 in front. So that's 1009.7. So this is probably the 1008 millibar. Oh, no, it's not. Oh, that's really interesting. 1010, 1011. So that was 8. So this is 1012. That makes sense. 1012. So it's in between 14 and 1009. Right. It's in between 1017 and 1010. So there's the 1012 millibar isobar. So that was a brief glimpse of the daily weather map. Again, weather station model. Let's take a look at you and see what we've got. Air pressure trend, it's up 4. I don't really care. Sky cover, it's 100%. Visibility, 8 miles. Don't really care. Let's take a look at another weather station model. So we've got, I want to know the temperature, the dew point temperature, the air pressure, the pressure tendency, the sky cover, the wind speed, the wind direction, and the current weather. Alrighty. So let's take a look. So for this, I want to know the temperature, the dew point temperature, the air pressure, the pressure tendency, the sky cover, the wind speed, the wind direction, and the current weather. I would suggest pausing this. Go ahead, pause the video, and after you've got it figured out, press play and see if you're correct. All right, let's see what we have. Temperature, 52 degrees. Dew point temperature, 50 degrees. Air pressure, 141 is what's written. So remember, if it's between 000 and 509, you throw a 10 on the front and then move the decimal place over 1 to the left. So 141, stick a 10 on the front, divide by 10, you get 1014.1 millibars. The pressure tendency is down by 11 millibars. Sky cover is 100%. Wind speed is 5 knots because it's just got a little half bar in the middle of the shaft. Wind direction, it's 90 degrees. It's coming from the east, flowing to the west. And the current weather, this little symbol is continuous drizzle. Continuous drizzle. So, like I said, we've got the temperature, we've got the dew point temperature, and so I'm going to want you to figure out things like the specific humidity and the relative humidity. So if we know what the dew point is, and I've made up a sheet for you, this is a chart of maximum specific humidity using Fahrenheit. So at 50 degrees, the maximum specific humidity is 7.6 grams of water vapor. So if we know what the dew point temperature is 50, we just look it up on the chart. I'll give you a link to the chart. So we know what the specific humidity is, 7.6 grams per kilogram. And then we can also figure out what the relative humidity is. So to calculate the relative humidity, we know what the temperature is, it's 52 degrees. We know what the dew point temperature is, it's 50 degrees. So we can look it up on the chart, and looking it up on the chart, we know that the current specific humidity given a dew point of 50 degrees is 7.6 grams. And knowing that the temperature is 52, the maximum specific humidity at 52 degrees Fahrenheit is 8.2 grams. So 7.6 divided by 8.2 times 100 gets us the relative humidity of 93%. So again, we've got another, I think this is our last example. Again, I would say take a look at it, pause it for a second, and see if you can't answer the questions of temperature, dew point, air pressure, pressure tendency, sky cover, wind speed, wind direction, and current weather. So the temperature is 56, the dew point is 32, the air pressure is 1013.7, the pressure tendency is up 3 millibars in the last hour. We know the sky cover is 100%, the wind speed is 5 knots as shown by a half bar. The wind direction is 180 degrees, and the current weather, as shown by this little squiggly symbol, is visibility reduced by smoke. So that's it for how to read the weather station on weather maps. I hope you enjoy this lab. I hope it's less stressful than the previous labs. There should be far less math. I'm going to ask you to calculate a couple relative humidities, but really, that's all the math in this lab. I hope you like it.